Hey everybody. I'm so sorry about that. I am recording. Thank you. Thank you very much for the kind welcome. Um, okay. Hey guys, thank you so much. All right, so I am pinned. I'm good. I always like to imagine how funny that would be if we were in like an in-person class and I just kind of abruptly like stepped out and then I was like, sorry, my internet died. I had to disappear for a second. Um, but thank you guys very much for your patience on this. Okay, so I'm back to recording. Okay, cool. So I don't have a new chat, but I have got this, or sorry, I have a new chat, so I don't have the old one. Um, we're on this slide where we're talking about protein interactions. I think the last thing that I saw was Chris contributed with ionic bonds. The two amino acids that could have the ionic bonds were arginine and aspartic acid. Then we've got our disulfide linkages, which cysteine are two amino acids that can make a disulfide linkage. Then last but not least is dispersion forces. These are attractive forces between two non-polar side chains. Okay, so this is just kind of a rundown of all of the different types of interactions for ways to link protein chains or for interactions between amino acid R groups. Now, have we talked about hydrogen bonds outside of amino acid R groups? Yes, we have. Because we talked about hydrogen bonds as part of the secondary structure, in which case we were talking about backbone interactions. So, one other way that I want you to think about this is hydrogen bonds can stabilize the secondary structure and the tertiary structure. Okay, but wait, how? Well, when it comes to, I'm going to say BB or backbone hydrogen bonds, secondary structure. And then whenever I say, actually, I'm going to draw a longer line here, hydrogen bonds, R group. Well, R group hydrogen bonds, it's the secondary structure, or sorry, not secondary structure. It's the tertiary structure. Then the last part about this is or quaternary structure. Now, that's because amino acid R groups, they can interact to form hydrogen bonds. And the question is, let me try to think of a or quickly come up with a hypothetical question. Um, yeah, here we go. Two polypeptides interact, and I will use this word quite a lot, via, or another way of thinking about that word is through H bonding between serine and THR. Now, one detail that I want you to know about this potential question is this is not this question does not require you to know the structure of serine or threonine. So this detail right here isn't going to be a part of the, well, is that true or false? That is absolutely true. That part of the stem is not something that you have to verify because the question is going to be, this is an example, an X of primary, secondary, tertiary, or quaternary structure stabilization. So we've got, and I'm going to work through this with you guys. We have two polypeptides. That stem right there should make you think, okay, two polypeptides, two separate things, two proteins. Well, anytime I'm talking about more than one protein, add to the chat which level of structure am I talking about when I'm talking about more than one polypeptide? Quaternary. So as soon as I see two polypeptides, I can kind of stop reading the question. I mean, it's always important to read a question completely, but as soon as I see that, my first thought is, okay, I'm probably talking about quaternary structure. I'll keep reading, interact through hydrogen bonding between serine and threonine. Okay, well, that doesn't change my answer. Nothing about that changes my answer. So my answer is going to be quaternary structure. Can anyone add to the chat that, yeah, I gotcha, makes sense? Or something along those lines. An emoticon, a yes, a Y, thumbs up. And if it's like, I'll get there, then that's fine. Okay, cool. I got some yeses. Okay. Now, okay, so the individual serine would be, Chris, great question. The individual serine would be within one of the polypeptides. So think about it like this. Here's polypeptide number one, SER, end of the polypeptide, and then here's the other, THR. And then here's my dashed line to show those two interacting. And heck, you know what? If I were to give you that picture right there, and let me add a little bit more detail, N to C and to C, then that's getting me to, all right, well, what level of protein structure is that? Primary, secondary, tertiary, or quaternary? Well, I've got two N termini and two C termini. Well, those are two independent polypeptides. So you're just showing that the series, to simplify the chain. Chris, 100%. Yes, 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 yes. Perfect. Well done. Absolutely awesome. Yes. That's fantastic. Yes, that's a great understanding because that, yeah, protein can be hundreds of amino acids long. Thank you. That's a fantastic question. Pat on the back. Okay. Now, the next slide is basically just here are some examples. Now, what I want you to be able to do is think about what are the interactions that can exist. And what I'm most interested in, these. And this is just to illustrate, okay, positive and negative, so that you can go to, okay, I know which one are my polar negative amino acids, and I know which are my polar positive amino acids. So your polar negatives would be something like ASP and GLU, aspartic acid and glutamic acid. My NH3, my positive, or my positives here would be something like LYS, ARG, and HIS. Then these right here, my disulfide linkage, cis and cis. Now, these are the ones that I put boxes around. I want you to be able to recall those specific amino acids. Hydrogen bonding, that's something where I will say, this amino acid, like I did on that previous question, serine and threonine interact through hydrogen bonding. I'll give you that. Now, last but not least, this right here, dispersion forces. What do you notice about these two groups? And before you answer, I want to ask you, do you see any oxygens or hydrogen, or sorry, any oxygens or nitrogens on either of those groups that are highlighted by our dispersion forces? Answer that in the chat. Yes, London dispersion forces, perfect. So Since there's not any nitrogens or oxygens there, what did we kind of use as like a as kind of an idea, like when we see an oxygen with a lone pair of electrons, what does that typically mean? An oxygen with lone pairs, polar. Okay. Here we don't see any oxygens, certainly no lone pairs of electrons. I mean, to be kind of frank with you, we see a bunch of carbons and hydrogens. A little bit boring. So, with that, how would you classify these two molecules or these two groups that I have stars by? Would you say they're polar or non-polar? Non-polar. So, I want you to, whenever you see dispersion forces, I want your mind to immediately go to, okay, NP, non-polar. Those are the types of interactions that occur when you have two non-polar, or sorry, when you have non-polar groups, you've got two dispersion forces. And think about the hydrogen bonding prompt or a question related to hydrogen bonding and a question related to dispersion forces. If I'm going to give any, or if there's detail needed to answer the question, I'm going to give you that detail. For instance, I would say something like, um, for dispersion forces, my question's probably going to be these types of AA interact through DISP forces. And then your answer option would be something like positive, negative, polar, and D, nonpolar. Go ahead and add to the chat which you think is the right answer, A, B, C, or D, to that question right there. A is positive, B is negative, C is polar, or D is nonpolar. Yep, nonpolar. Nonpolar amino acids will interact through dispersion forces. Okay, so that's where I wanted to go ahead and get today in terms of protein structure. The next few slides, let's review amino acids and proteins. These are mostly just blank slides. And I think what's a good idea is to just kind of put together a little map for yourself and say something like ASP. What can that interact with? Well, HIS, ARG, and LYS. You can make like a little network for yourself and say like, okay, well, lysine can interact with GLU. So too can arginine. So too can histidine. You can make a little map like that. And then CYS, CYS, cysteine, cysteine. That's I was gonna say, well, that's pretty much it. But yeah, that's pretty much it. Any other details about the identity or the atoms that make up an amino acid R group, I'd provide that for you. Um, and so, you know, one question that I might ask, I could give you a picture of a structure. So I want you to be able to identify, oh, is this a polar group? How would I define this? Other than that, though, I want you to recall those 5 amino acids, and I'm just going to add the sixth of that cysteine residue. Um, At any rate, that's where I'm going to stop because that's all I got for today. I want to say thank you very much for your patience and hanging around as my internet decided to restart. I hope that doesn't happen again. I'll be posting today's lecture in 2 items. Um, I hope you have a great afternoon, and I'll be in my office hours in about 13 minutes. So if you got some more questions, feel free to drop by. Expect the quizzes to be posted this evening, and I will see you guys later. Thank you very much for coming, everyone.